0. And for me, that's sort of like the pivotal point. That's the one I really kind of follow for all my logs. It's usually at this point that they start to really bend. You know, it's like, I keep saying boomerang shaped. That's when sort of like the bend happens, okay? Then the other points, my base comma 1. Well, the base for this function is 1/2. So I'm going to go to where x equals 1/2, and that's when the y value gets up to 1. And then the third point is the reciprocal of the base, and since my base is 1/2, its reciprocal is 2. So I go out to where x equals 2, and that's when the y value equals -1. Okay? And then we have a vertical asymptote at the y-axis. Our logs don't cross the y-axis because I remember writing something on the board about this. The domain for our log function is positive values only. We can't plug in the log of a negative number. Does that ring a bell?
Yes.
I use big letters. Okay. So we got this function here, which is a decreasing function. From one point to the next, we keep going down, 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 down. At some points, more starkly than in others, but they still do continually go down. Its domain is all real numbers. Sorry, its domain is 0 to infinity. Its range is all real numbers. All that stuff. Okay. So this is just a straightforward graphing a log function. Okay. Now I did some embellishing over here for the next one.
Well, you said that was in 1 and 4. I'm just going to know the quadrants correctly. What are the quadrants on the graph?
They start here. This is quadrant 1, where everything's positive, and then you go counterclockwise.
Okay, I was wrong. I have the graph right, just the quadrant 1. Okay.
When you said 2 and 4, I thought you had done this.
No.
Yeah, that would have been.
I knew what you did. I just got the wrong. I thought it started on the other side. Okay.
Okay. So right here, I did some embellishing to my log function, right? I'm doing some of my graph transformation, some of my translating stuff. So I went ahead and threw both of them at you. There's one of them that's inside the log function, and one of them that's outside the log function. Agreed?
Agreed.
Okay. So the ones that are inside the function, do they move my graphs vertically or horizontally?
Horizontal.
Horizontally. And so the -3 that I'm doing here, that's inside the log function, is that left or right?
Right.
Okay. And so then the one that's outside the function, the adding 2, I put that in a different place than we normally do. And I have a reason for that, and we'll get to that in a little bit. But that adding 2 right there is going to move all of my points up 2 units. Right? Tell you what, let's go ahead and talk about that now. Have you guys noticed that your log function doesn't always use parentheses? Have y'all seen notation like that before? You've seen it? Maybe not a lot, but at all? I mean, is there anyone that's never seen it written like this before? Never ever at all? Okay. Here's the thing. Sometimes we get lazy with our notation. I don't really like to write it without parentheses, and I've got a handful of reasons why. But one of the reasons why I don't like to write it without parentheses is, what if I'm doing that? Where am I adding to?
Today.
Is that inside the log function or outside the log function? You could argue it either way. And whether it's inside or outside makes a difference, right? Because if it's inside, then it moves it left 2. But if it's outside, then it moves it up 2. And going left is different than going up, right? And so you'll see me, even if it's just an x, I'm going to always put parentheses here. The other reason why I like that is I want to reaffirm, I don't know that we've mentioned this, that this notation is the same as that notation. This is the function named f as it depends on the value of x. This is not multiplication or anything like that, right? Ditto here. This isn't log times x. This is the function named log base b as it depends on the value of x that I'm plugging in. The x in parentheses here is the same as x in parentheses here, right? So I prefer to use this notation, but I'm kind of swimming against centuries of other math people who kind of, over time, really dropped the parentheses. So you'll see textbooks that will write it like this. If you see it written like this, you have in parentheses understood just an x. It would mean that, which means it would be adding 2 outside, but that's unclear. So one of the things I will do, not every time, but most of the time, is if I'm adding something inside, or I'm sorry, if I'm adding something outside the log function, I'll put it out front. That way there's no way of confusing that, right? I mean, if it's out front, it's definitely not in the log function. Okay, so let's go back to this one and graph it. Okay, like we did with the exponential function, let's start by plotting the points before we shift them 3 and 2. Okay, so the first point I almost always plot is the 1, 0 point. And I want to move that right 3. 1, 2, 3. But I also want to move it up 2. So the 1, 0 point moves to 4, 2. What would be a second point that I would have plotted for this log function before shifting? 5 comma what? 1. Yeah, 5 comma 1. That one there. But I'm going to have to move that right 3 and up 1, 2. Sorry, still working on my numbers. So 1, 2, 3, up 1, 2. So that goes through 8, 3. And the third point that I would have plotted before shifting,
1 over 5.
yeah, 1/5, which is a really small number, close to 0, right? 1, 2, or whatever, comma negative 1. So that one right there. And going right 3 is a little tricky. It's right after 1, right after 2, right after 3, and up 1, 2. So right there. What else moves right 3 and up 2? The asymptote, right? I have a vertical asymptote, and I'm going to move it right 3 units. If I move it up 2 units, I don't really tell a difference, so. Right, so if I move it right 3, instead of being the y-axis, it's now at x equals 3. And remember, I'm going to be grading you partially on, you don't pass your asymptote when you draw your curve, right? You need to stay on this side of the asymptote. Look at that. That's gorgeous. And then you get that shape. Now, because I did some translating, my domains and my ranges changed, possibly, right? So, is the domain for this still 0 to infinity? 3. Yeah, the smallest x I can plug in is not even 3. It's got to be bigger than 3, right? But then, as those x's go, I can still go to positive infinity. And my range, it's still all real numbers. So there's really not much I can do to that to change the range from being all real numbers. There's one thing I can do. I don't remember if I assigned that as a homework question or not. Do y'all remember seeing an absolute value in the homework yet?
Yes. Yeah.
Okay, cool. Alright, so talking about this domain being only 3 or bigger, what happens if I actually try to plug in 3? What's 3 minus 3? Oh, this is an easy one. We taught you this one in first grade. 3 minus 3 is? And what happens if I try to take the log of 0? You fail. Okay? If I go left of 3, even if I do like 2 or 1, these are positive numbers, right? But if I try plugging in 2 or 1, 2 minus 3 is negative 1. You can't take a log of a negative 1. So it doesn't really matter if the x is positive or negative. What's ultimately going to matter is what am I trying to take the log of? That's going to be the problem, right?